So in Chapter 6, we start using the quantitative information that's contained within chemical formulas and chemical equations to do some math. And most of this math is going to be concerned with using conversion factors. And conversion factors, as you know, are just fractions. And they're fractions with different units on the top and the bottom. And the units are set up so that they cancel the units that we want to get rid of, and they leave us with the units that we would like in our answer. So if I was to multiply that conversion factor there by grams, I would be left with milliliters. So in this introduction, what we're going to do is run through the general guidelines for using conversion factors in different settings and the types of conversion factors that we're going to see. We're going to introduce a mathematical concept called dimensional analysis, and dimensional analysis is really key to success in forming in performing these mathematical operations that we're going to be doing in the subsequent sections of Chapter 6 correctly. So dimensional analysis is a technique that we use to help where we use the units to help us confirm that we've set up the calculation correctly. And it's really important to get in the habit of using this method that I'm showing you, using conversion factors, and then to abandon any other methods that you might have been taught in the past, like the railroads method or so forth. Those things tend to break down once we get into more complex problems. So in this technique, what happens is that the units are going to be treated algebraically. They're going to be multiplied, they're going to be divided, they're going to be cancelled, they're going to be raised to the power of a given exponent, things like that. Okay. So the general kind of process that we'll be using to do a unit conversion is we're going to be given some quantity. And we're going to recognize what that quantity is and what its units are. I'm going to write that down. And then I'm going to write that down on the left of our page. And then over on our far right of our page, we're going to have an equal sign, and we're going to have some units that we're trying to transform into. And that information is always going to be given to you in the problem. It just might be kind of like hidden behind a lot of language, and you have to kind of read through the problem and digest it. And you've seen a little bit of that already in Alex. Then what you're going to do is you're going to take the quantity that you were given, and you're going to multiply it by one or more conversion factors, sometimes up to 4, and that ultimately lead you to the units that you want. And so what are these conversion factors? They're fractions, right? They're fractions that have the same size thing on the top and the bottom, but with different units. And then what you do is, before you kind of enter numbers into your calculator, you'll cancel out all the units that you can and make a note that you are left with the units that you want in your answer. And at that point, you do the math and you work out your significant figures. So it kind of sounds complicated, but it's pretty easy once you get in the groove of doing it. So here's a good example. It says a tablet of aspirin contains 0.25 grams of aspirin. How many milligrams of aspirin does the tablet contain? So this is kind of a trivial example, but we're going to go through it. So this is what we're starting with. This is what we're ending up with. And we're going to multiply by one or more conversion factors until we get what we want. Now, the conversion factor always has the same unit top and bottom. So I know that when I'm writing out this conversion factor, to do this, it has to have grams on the bottom there to cancel out my grams. It needs to leave me with milligrams, so it must have milligrams on the top line. So this guy is nice and simple. We can do this in one step, and I know before I put anything into my calculator that I'm going to end up with the correct units, right? So when I'm thinking about the conversion factor that I'm going to be needing, I'm relying on the relationship between milligrams and grams, and I'm going to take this equality here, and that's going to lead me to my two conversion factors. And like I said, we always pick the conversion factor that has the units we want to eliminate in the correct position and the units that we want in our answer in the correct position. So that's just kind of the general, how we use a conversion factor. We've seen this before. Okay, here's one here where I've got two metric units of length, but they both have a decimal prefix. This one is going to be a little more complicated. So I want to go from centimeters to millimeters. So something to be aware of is whenever you have a metric prefix in both your answer and your starting units, it's always best to go through the base unit. So the base unit of length is the meter in this case. So my pathway is going to be like this: centimeters to the base unit, which is the meter, and then finally onto millimeters. So I'm actually going to do two conversions here. So in my first conversion, I'm going to take centimeters and turn it into meters by multiplying by the conversion factor that relates meters and centimeters, and then that gets me there. And then I'm going to go on, and you can see that whatever's there automatically goes there. I'm going to go from meters into millimeters, and there I am. I've got my answer, right? So I know I've got it set up right. You can see here that I always have the 1 beside the unit that has a prefix. That can be really helpful to let you know you're on the right track. The 1 always goes beside the unit that has the prefix, and then the power of 10 always goes beside the base unit. What is the power of 10? It's just the number that's equal to the decimal prefix, right? You see that? The 1 goes next to the unit that has the prefix. The power of 10 goes next to the base unit. Pretty simple idea. Okay, units cancel. Check that what you've got left over is what you want, and away you go. You're on. Now, where things can get complicated is where your units have a power associated with them, because in this scenario, you will have to raise your conversion factor to that power. So you've got to keep that in mind. You can't not do this. You'll get horribly, horribly wrong answers if you don't do that. Okay, so I need to turn 2.5 by 10 to the minus 6 kilometers cubed into centimeters cubed. So this is going to be my setup. Now I note that both of these guys are metric units that have a prefix. So I know I'm going to go through the base unit. So I'm going to go from kilometers cubed to meters cubed to centimeters cubed. And then the other thing that I'm paying attention to is the fact that my conversion factor is going to need to be cubed. All right, my conversion factor will need to be cubed. So here's what I'm starting with. And then I'm going to multiply it by my conversion factor that gets me to meters cubed. And I know that in 1 kilometer, I have 10 to the 3 meters, but I've got to cube that guy. If you don't cube it, you're going to be in a world of pain. That's going to get me to meters cubed. Now I know I've got to get it all the way up to centimeters cubed, and I know that in 1 centimeter, there are 10 to the minus 2 meters. And again, that has to be cubed. If you don't cube it, and I don't know why, I would say like 30 to 40% of people stubbornly refuse to cube their conversion factors and just get these wrong every time. Yeah, it's just how it is. And then that'll get me all the way through to my centimeters cubed. Now, I've evaluated what happens when you cube these things. You don't need to do that as a separate step, okay? You don't need to do this. Your calculator will handle that fine. You can just enter what's in the middle row there in step 2 into your calculator to get your answer. So do the units cancel? Kilometers cubed, meters cubed, everything cancels. There you go. And there's my final answer with the correct units. Okay, so that's tricky if you have to square or cube your conversion factor. You just got to remember to do it. All right. Here's one where we're doing some conversions within the traditional system of units. So it says, in the mornings, I like to drink a 20 fluid ounce coffee. That's a big one, right? What is this volume expressed in gallons? I'm going to need to know how fluid ounces is related to gallons. Now, when I looked in the book, they didn't have any relationships between fluid ounces and gallons, but they did have a relationship between fluid ounces and quarts. And then I knew that 4 quarts equals 1 gallon, but they also had that in my book as well. So what I'm going to do is go from fluid ounces to quarts and then over to gallons, because that's the conversion factors that I had available to me. All right. So what's going to happen here? I know that in 1 quart there are 32 fluid ounces, so that's going to get my conversion there. And then I know, as I mentioned before, that there are 4 quarts in 1 gallon. So in 1 gallon there are 4 quarts, and then that's going to get me the rest of the way. I started with 3 significant figures. The only operation that I'm doing here is multiplication. This is exact because it's a unit definition. This is exact. It's a unit definition. So my answer needs 3 sig figs. Okay. Next one. In this case, I'm going to take kilograms and I'm going to turn it into pounds. And I'm given a little bit of extra information. So that's cool. Now, what I can see here, though, is that my relationship between pounds and the metric system is the relationship between pounds and grams. So this guy is going to need to go through grams, isn't it, right? And that often kind of comes up, that sort of thing. So it's going to go kilograms to grams to pounds. Okay, that's how we're going to go here. So my conversion factor for the kilograms to grams is based on using those metric prefixes. And I know that kilo just means the same thing as 10 to the 3, right? So 10 to the 3 grams in 1 kilogram. Note how the 1 always goes next to the thing that has a prefix. So the kilograms cancels out. There we go. And now we get to apply this guy. Here we are, 1 pound, 453.6 grams. Grams cancels out, leaves me with pounds. It's about 2.2 pounds to the kilogram, so this looks good to me. It's always a good idea to have in the back of your mind what the answer should be. 43 kilograms expressed in pounds, I know it's a little over 2 pounds per kilo, so before I do this, I know it's going to be a little bit bigger than 86. I know it before I get in there, not much bigger than 86. So if I got 950 pounds, I'd know that I was wrong. So it's always a good idea to have that in the back of your mind. What is the answer that I'm expecting? And then do that double check at the end. All right, so we're just reviewing using conversion factors here. These problems we're not particularly interested in. We're just reviewing them because we're going to be relying so heavily on these guys when it comes to the next sections in chapter 6. So keep that in mind. These are not like the actual details of these calculations. What we're converting isn't important here. It's more about how we're using our conversion factors that I want you to kind of focus on. Okay, here's another one where we've got a cube in here, right? So it says a can of soda contains 375 milliliters. What I want you to keep in mind is that 1 milliliter is exactly the same as 1 centimeter cube. They are both units of volume, and milliliter is just kind of like an abbreviation for centimeters cubed. So keep that in mind, that we could just as easily write this as centimeters cubed. We're going to turn this into cubic feet. The fact that that's got a cube there makes me really cautious that I'm going to have to cube some conversion factors. So in my mind, the logical pathway is to go from milliliters to centimeters cubed. They're just going to be equal, right? And now centimeters is a unit of length. So I'm going to go from centimeters to inches because in my book is a conversion factor that relates centimeters and inches. And then I know, just from general knowledge, that there are 12 inches in a foot. I'm being really aware that when I do these conversions with the cube there, that I'm going to need to cube my conversion factor, okay? So this is my pathway, right? 375 mils, multiply it by the conversion factor that it has mils on the bottom and centimeters cubed on the top, and that's kind of a no-brainer. 1 centimeter cube is the same as 1 mil. Then in my book, they had a relationship between inches and centimeters, and this is what it was right here. So 1 inch is the same as 2.540 centimeters, but remember I got to cube it because I'm trying to cancel centimeters cube and I'm trying to generate inches cubed. So having multiplied by this guy, I'm now in inches cubed. And then finally, I would need to do my conversion to feet cubed, and I know 1 foot is the same as 12 inches, but again, I got to cube my conversion factor, right? And then that's going to get me to where I want to be, to feet cubed. As I said, you don't actually have to evaluate these terms here. You can just put this into your calculator exactly as it is here and it'll give you your answer. I did evaluate them here just to show you the cancelling of the units. There we go. Boom. And you can see that this clearly leads from milliliters all the way down to feet cubed. Now, you're not going to get very many feet cubed in a can of soda, right? So 1 foot cubed is like bigger than a shoebox. It's like 2 shoeboxes. It's 1 foot by 1 foot by 1 foot. A can of soda is not the size of 2 shoeboxes, right? Unless it's like I don't know if they do like the giant cans of beer or something. But you know, a regular can of soda is not that many cubic feet. So the fact that I got 0.0132 cubic feet makes sense to me. Okay, so now we're going to get into some more complex conversion factors that have sort of different types of quantities on the top and the bottom. So let's have a look at this. So you've already encountered this. So many units in chemistry involve more than one type of measurement. That is, they have complex units. So some familiar examples of this would be miles per hour, where the measurement has a unit of length and a unit of time. Density, which is often expressed as grams per liter, has got a unit of mass and a unit of volume, right? All in the one unit. So this is kind of like interesting, right? So there's a couple of things that can happen here. If I'm going to convert miles per hour to meters per second, I actually have to do 2 conversions. I have to convert the miles to meters, that's the length part of the conversion, and then I have to convert the hours to second, that's the time part, right? So it can get complicated, you know, it can get complicated. Miles per hour, if I'm doing 60 miles per hour, but it can be written like that, but it's also completely valid to say that in 1 hour there are 60 miles, right? So we also need to be aware that these conversion factors with these complex units, they can be written either way up, just like any other conversion factor. So let's have a look at what we've got going on here. It says global emissions of carbon dioxide are estimated at 2 billion tons per year. Convert this rate to pounds per hour. So you can see I've got 2 conversions to do. I've got to turn years into hours, and I've got to turn tons into pounds. All right, so I've got to find out how these things are related. It turns out that there are 2,000 pounds in 1 ton. Okay, I just had to look that up. Now, years and hours. Well, most people know that in 1 year there are 365.25 days, and then they know that there are 24 hours in 1 day. So for most people, they don't know how many, hours there are in a year, right? So we're gonna do things like this. All right. So let's set it up. My pathway is going to be for the pounds. From the tons, I'm going to go directly to pounds. For the years, I'm going to go years, days, and then finally hours. So that's what's going to happen. All right, here we go. So 2 by 10 to the 9 tons per 1 year. I'm going to turn the tons into pounds. 2,000 pounds per 1 ton. The tons are gone. So I'm done with that guy. I'm done with the top line. Now I'm going to start working on the bottom line. So I've got to get my years and I've got to turn them into days. So I need my years on the top line. There they are. And I need my days on the bottom line. So this is going to get rid of years and turn them into days. And then now I need to turn my days into hours. So what I'm going to do is make sure I've got my day on the top line and my hours on the bottom line. There we go, and it leaves behind hours there and pounds there. And now I have it in pounds per hour, ready to roll. Okay, so sometimes when we're doing conversions, we're going to have these like complex units, and they're normally like something per something. And you've already seen that in Alex. That was deliberate to give you a little bit of practice using those types of conversion factors. You know, just to kind of get you cruising with it, because we're going to be using them a lot for our case study this week, and the case study is worth a lot of points. It's also hard. Okay, so that concludes the introduction, where we talk about how we use different conversion factors and some of the more complex scenarios that we're going to see, where we're like cubing, or perhaps we're going to be squaring a conversion factor, and also those examples where we have complex unit conversions involving things that have, you know, different types of quantities on the top and the bottom line of our conversion factor. Okay, hope the video was helpful.